All right. Any ideas how to solve this problem? Did I lose you guys?
We can determine the energy emitted by the electron given that we are given
Okay.
N3 and N1.
Do we need to go to energy? Is there an equation that might directly get us to where we want to go? Do you remember that Rydberg equation? What was that? Let's revisit the Rydberg equation. I don't remember how to spell his name. R-A. Let's hope this is how you spell it. The Rydberg equation had the wavelength in there. All right. And then where N2 is greater than N1. Whoa, what was that? And this was the Rydberg constant, which is one something I can't remember. Let's look that up. I'm old. I'm forgetting my constants. I used to know all these guys by heart. At 109737316, which do we need to go to that detail? I would imagine not, but okay, let's just go ahead and put it in 1.0 737316. And it was 7th. Okay, so that's what goes right here. So if we know that, it's just a matter of algebra and plugging and chugging. You guys see that? Because all I got to do is solve for lambda. I'm just going to leave that as RH. We know that it's referring to this wonderful constant here. And then not equal, sorry, there should be a parentheses. What goes next? We were going from 3 to layer 1. Is this a emission or is this an absorption of energy into the by the electron? Is it fluorescing or is it giving off light or is it absorbing?
Emission?
Good, right? Because it's going from 3 to 1. So it's giving off energy. We'll see a spectra from it. But thing I put there. We're going from layer 3 to 1. So this would be N3, right? So here we would plug in a 1. Here we would plug in a 3. Okay. And we're looking for a wavelength, so hopefully it's positive, right? Try to make sure it makes sense mathematically as well. Distance has to be positive. So now it's a matter of subtracting. Here we're going to have 1 minus 1/9, so that's 9/9. So that's RH times 8/9 equals 1 over lambda. Since we're looking for lambda, what we can do is we can either cross multiply and divide, or we can just say this whole thing is a numerator, and we can flip both sides. Okay, so when I do that, I get that lambda should come out to 9. Oops. 8 times Rydberg's constant. Whatever that value is your lambda. Okay, and make sure you put it in SI units if they ask for it. Now the answer to this is in the last page of your chapter, as well as the other problems within the text. Any questions?
No.
No.
Okay. Then the book goes into waves and the different properties that they have and how guitars can help you visualize and conceptualize this. I suggest you read this, but it essentially has to do with how the waves are quantized and the wavelengths. But from this stems the de Broglie equation that is the only wavelength equation that has mass in it. So keep an eye out for something like that. But de Broglie is here. So the particle and its wave properties have this relationship. If I could get this thing to cooperate. There we are. Lambda equals Planck's constant. Mass over U. What is U? Anybody? Velocity. Tell me how that makes sense. I don't know. Their symbols sometimes are baffling. Okay, so this U right here is velocity. Keep that in mind.